At Paris, the change exceeds 11 degrees in an hour. Thus, supposing the oscillations to commence in a plane directed south and north, in 2 hours the oscillations will point south-southwest and north-northeast. In 4 hours they will point southwest and northeast. And in 8 hours the oscillations will point due east and west, or at right angles to their original direction. To a spectator, the changes seem to be in the pendulum, which without any visible cause has shifted round a quarter of a circle. But the real change is in the table, which, resting on the earth and accompanying it in its rotation, has performed a fourth and something more of its diurnal revolution. No one anticipated such a result, and the experiment has been received by some with incredulity, by all with wonderment, and one source of the incredulity arises from the difficulty of conceiving how, amidst the 10,000 experiments of which the pendulum has been the subject, so remarkable a fact could have escaped notice so long. Fully admitting that these experiments have generally been conducted with pendulums which had little freedom of motion horizontally, we still think it odd that somebody did not stumble upon the curious fact. Though all parts of the earth complete their revolution in the same space of time, it is found that the rate of horizontal motion in Foucault's pendulum varies with the latitude of the place where the experiment is made. At the pole, the pendulum would pass over 15 degrees an hour like the earth itself, and complete its circuit in 24 hours. At Edinburgh, the pendulum would pass over 12.5 degrees in an hour, and would complete its revolution in 29 hours, 7 minutes. At Paris, the rate of motion is 11 degrees and 20 minutes per hour, and the revolution should be completed in 32 hours. Section 12, Figure 1. Let the above figure represent a portion of the Earth's surface near the North Pole. N supposes the pendulum to be set in motion at M, so as to vibrate in the direction of XY, which coincides with that of the meridian line. MN has come in 6 hours into the position NN. It has been hitherto supposed that the pendulum would now vibrate in the new direction of NN, assumed by the meridian, but thanks to M. Foucault, we now know that this is a mistake. The pendulum will vibrate in a plane XNY parallel to its original plane at M, as will be manifest if the plane of vibration points comes to some object in absolute space, such as a star, while the meridian line MN will in the course of 24 hours range round the whole circle of the heavens and point successively in the direction of NN, or ON, or PN, then RN, SN, TN, and finally UN. The pendulum's plane of vibration XY, whether at M, at N, at O, at P, R, S, T, or at U, will always be parallel to itself, pointing invariably to the same star, and were a circular table placed under the pendulum, its plane of vibration, while really stationary, would appear to perform a complete revolution. This stationary position of the plane of vibration at the pole seems to present little difficulty. We impress a peculiar motion of the pendulum in setting it a-going. The Earth is at the same time carrying the pendulum eastward, but at the pole the one motion will not interfere with the other. The only action of the Earth on the pendulum there is that of attracting it towards its own, the Earth's center. But this attraction is exactly in the plane of vibration and merely tends to continue with the oscillatory motion without disturbing it. It is otherwise if the experiment is made at some other point, say 20 degrees distant from the pole. Supposing the vibrations to commence in the plane of the meridian, then as the tendency of the pendulum is to continue its vibrations in planes absolutely parallel to the original plane, it will be seen, if we trace both motions, that while it is carried eastward with the Earth along a parallel of latitude, this tendency will operate to draw the plane of vibration away from a, quote, great circle into a small circle, that is, from a circle dividing the globe into two equal parts into one dividing it into two unequal parts. But the pendulum must necessarily move in a great circle, and hence to counteract its tendency to deviate into a small circle, a correctory movement is constantly going on, to which the lengthening of the period necessary to complete a revolution must be ascribed. At Edinburgh, the period is about 29 hours. At Paris, 32 hours. At Cairo, it's 48. Calcutta, 63. At the equator, the period stretches out to infinity. M. Foucault's rule is that the angular space passed over by the pendulum at any latitude in a given time is equal to the angular motion of the Earth in the period, multiplied by the sine of the latitude. The angular motion of the Earth is 15 degrees per hour, and the latitude of 30, for example, the sine being the radius as 500 to 1000, the angular motion of the pendulum will consequently be 7.5 degrees per hour. It is therefore easily found. It follows that the motions of the pendulum may be employed in a rough way to indicate the latitude of a place. End quote. Notwithstanding the apparent certainty of these pendulum experiments and the supposed exactitude of the conclusions deducible therefrom, many of the same school of philosophy differed with each other, remained dissatisfied, and raised very serious objections to both the value of the experiments themselves and to the supposed proof which they furnished of the Earth's rotation. One writer in the Times newspaper of the period, who signs himself B.A.C., says, "I have read the accounts of the Parisian experiment as they have appeared in many of our papers, and I must confess," this quote's coming from Supplement to the Manchester Examiner, May 24th, 1851, "and must confess that I still remain unconvinced of the reality of the phenomenon. It appears to me that except at the pole where the point of suspension is immovable, no result can be obtained. In other cases, the shifting of the direction of passage through the lowest point that takes place during an excursion of the pendulum from that point in one direction and its return to it again will be exactly compensated by the corresponding shift in the contrary direction during the pendulum's excursion on the opposite side. Take a particular case. Suppose the pendulum in any latitude to be set oscillating in the meridian plane and to be started from the vertical towards the south. It is obvious that the wire by which it is suspended does not continue to describe a plane, but a species of conoidal surface, that when the pendulum has reached its extreme point in direction is to the southwest, and that as the tangent plane to the described surface through the point of suspension necessarily contains the normal to the Earth at the same point, the pendulum on its return passes through the same point in the direction northeast. Now, starting again from this point, we have exactly the circumstances of the last case, the primary plane being shifted slightly out of the meridian, when therefore the pendulum has reached its extreme point of excursion. The direction of the wire is to the west of this plane, and when it returns to the vertical, the direction of passage through the lowest point is as much to the west of this plane as it was in the former case to the west of the meridian plane. But since it is now moving from north to south instead of south to north, as in the former case, its former deviation receives complete compensation, and the primary plane returns again to the meridian when the whole process recurs." End quote. In Liverpool Mercury of May 23, 1851, the following letter appeared, quote, "The supposed manifestation of the rotation of the Earth. The French, English, and European continental journals have given publicity to an experiment made in Paris with a pendulum, which experiment is said to have had the same results when made elsewhere. To the facts set forth no contradiction has been given, and it is therefore to be hopeful that they are true. The correctness of the inferences drawn from the facts is another matter. The first position of these theorists is that in a complete vacuum beyond the sphere of the Earth's atmosphere, a pendulum will continue to oscillate in one and the same original plane. On that supposition, their whole theory is founded. In making this supposition, the fact is overlooked that there is no vibratory motion, unless through atmospheric resistance or by force opposing impulse. Perpetual progress in rectilinear motion may be imagined, as in the corpuscular theory of light. Circular motion may also be found in the planetary systems, and parabolic and hyperbolic motions in those of comets. But vibration is artificial and of limited duration. No body in nature returns to the same road it went unless artificially constrained to do so. The supposition of a permanent vibratory motion such as presumed in the theory advanced is unfounded in fact and absurd in idea, and the whole affair of this proclaimed discovery falls to the ground. It is what the French call a mystification, English a humbug." End quote. Liverpool, 22nd May 1851. Another writer declared that he and others had made many experiments and had discovered that the plane of vibration had nothing whatever to do with the meridian longitude, nor with the Earth's motion, but followed the plane of the magnetic meridian. Quote, "A scientific gentleman in Dundee recently tried a pendulum experiment, and he says that the pendulum is capable of showing the Earth's motion I regard as a gross delusion, but that it tends to the magnetic meridian I have found to be a fact." End quote. Liverpool Journal, May 17, 1851. In many cases, the experiments have not shown a change at all in the plane of oscillation of the pendulum. In others, the alteration in the plane of vibration has been the wrong direction, and very often the rate of variation has been altogether different to that which theory indicated. The following is a case in illustration. Quote, "On Wednesday evening, the Reverend H. H. Jones, F.R.A.S., exhibited to the apparatus of Foucault to illustrate the diurnal rotation of the Earth in the library hall of the Manchester Athenaeum. The preparations were simple. A circle of chalk was drawn into the center of the floor, immediately under the arched skylight. The circle was exactly 360 inches in its circumference, every inch being intended to represent 1 degree according to a calculation Mr. Jones had made, and which he produced at the Philosophical Society 6 weeks ago. The plane of oscillation of the pendulum would, at Manchester, diverge about 1 degree in 5 minutes, or perhaps very little less. He therefore drew his circle exactly 360 inches around, and marked the inches on its circumference. The pendulum was hung from the skylight immediately over the center of the circle, at the point of suspension being 25 feet high. At that length of wire, it should require 2.5 seconds to make each oscillation across the circle. The brazen ball, which at the end of a fine wire constituted the pendulum, was furnished with a point to enable the spectator to observe the more easily its course. A long line was drawn through the diameter of the circle, due north and south, and the pendulum started so as to swing exactly along this line, to the westward of which, at intervals of 3 inches at the circumference, 2 other lines were drawn, passing through the center. According to the theory, the pendulum should diverge from its original line towards the west, and at the rate of 1 inch or degree in 5 minutes. This, however, Mr. Jones explained, was a perfection of accuracy only attainable in a vacuum, and rarely could be approached where the pendulum had to pass through an atmosphere subject to disturbances. Besides, it was difficult to avoid giving it some slight lateral bias at starting. In order to obviate this as much as possible, the steel wire was as fine as would bear the weight, 1/30th of an inch thick, and the point of suspension was adjusted with delicate nicety. An iron bolt was screwed into the framework of the skylight. Into it a brass nut was inserted. The wire passed through the nut, the hollow sides of which were ball-shaped in order to give it a fair play, and at the top the wire ended in a globular piece, there being also a fine screw to keep it from slipping. Note: the pendulum was gently drawn up to one side at the southern end of the diametrical line, and was attached by a thread to something near. When it hung quite still, the thread was burnt asunder, and the pendulum began to oscillate to and fro across the circle. End note. Before it had been going on quite 7 minutes, it had reached nearly the 3rd degree towards the west, whereas it ought to have occupied a quarter of an hour getting thus far from its starting line, even making no allowance for the resistance of the atmosphere. End quote. Besides the irregularities of so often observed, the time and direction of the pendulum vibrations, and which are quite sufficient to render them worthless as evidence of the Earth's motion, the use which Newtonian astronomers made of the general fact that the plane of oscillation is variable was most unfair and illogical. It was proclaimed to the world as a visible proof of the Earth's diurnal motion, but the motion was assumed to exist and then employed to explain the cause of the fact which was first called a proof of the thing assumed. A greater violation of the laws of investigation was never perpetrated. The pendulum would pass over 12.5 degrees in an hour, and would complete its revolution in 29 hours, 7 minutes. At Paris, the rate of motion is 11 degrees and 20 minutes per hour, and the revolution should be completed in 32 hours. Section 12, Figure 1. Let the above figure represent a portion of the Earth's surface near the North Pole. N supposes the pendulum to be set in motion at M so as to vibrate in the direction. Notice so long. Fully admitting that these experiments have generally been conducted with pendulums which had little freedom of motion horizontally, we still think it odd that somebody did not stumble upon the curious fact. Though all parts of the Earth complete their revolution in the same space of time, it is found that the rate of horizontal motion in Foucault's pendulum varies with the latitude of the place where the experiment is made. At the pole, the pendulum would pass over 15 degrees an hour like the Earth itself, and complete its circuit in 24 hours. At Edinburgh, Oz has shifted round a quarter of a circle, but the real change is in the table, which, resting on the Earth and accompanying it in its rotation, has performed a fourth and something more of its diurnal revolution. No one anticipated such a result, and the experiment has been received by some with incredulity, by all with wonderment, and one source of the incredulity arises from the difficulty of conceiving how, amidst the 10,000 experiments of which the pendulum has been the subject, so remarkable a fact could have escaped. At Paris, the change exceeds 11 degrees in an hour. Thus, supposing the oscillations to commence in a plane directed south and north, in 2 hours the oscillations will point south-southwest and north-northeast. In 4 hours they will point southwest and northeast. And in 8 hours the oscillations will point due east and west, or at right angles to their original direction. To a spectator, the changes seem to be in the pendulum, which, without any visible cause, direction of xy, which coincides with that of the meridian line MN has come in 6 hours into the position NN. It has been hitherto supposed that the pendulum would now vibrate in the new direction of NN, assumed by the meridian, but thanks to M. Foucault, we now know that this is a mistake. The pendulum will vibrate in a plane XNY parallel to its original plane at M, as will be manifest if the plane of vibration points comes to some object in absolute space.